Hi folks, this is Doug from Mesh Energy. I'm recording this webinar for you on the RIBA 2030 Climate Challenge. Will your actions speak louder than words? This is obviously a pretty hot topic at the moment, and during this webinar we're going to take you through the actual framework itself as proposed, and then the second half of the webinar we're going to be focusing on our interpretation of how it's delivered, go into a bit more detail, and give you some more information on how we think you can practically make it work for your practice. Likelihood is we'll do lots of other webinars on RIBA 2030, and this is really just an initial introduction. So where do we start off? Just a really quick introduction about Mesh Energy. We're independent energy consultants, and put very simply, we partner with architects working on behalf of the clients, completely unbiased. We're interested in the right solution for the client and the building, and have no other kind of commercial pressures. And really, it's a pretty complicated world out there, so we're looking to simplify decision making and give some real teeth behind sustainability. And what I mean by that is be able to give numbers and feedback to the design team to really drive the project through to ultimate success. And a lot like a load of other sustainability consultancies, we can provide support at any stage. So whether that's pre-planning advice, post-planning advice, construction, and on to kind of post-occupancy evaluation if need be. But by way of a quick introduction, that's us, and that's what Mesh Energy does, and that's who's behind these webinars. So by way of an introduction, to give a bit of context to RIBA 2030, last year the RIBA declared a kind of a climate emergency, much like a lot of other bodies and councils. The RIBA declared this emergency, and I guess really that's a kind of a stake in the ground, in as much as they realise that something drastically needs to be done as an organisation, and is a starting point for them to do something and kind of roll this out and make something meaningful happen. The UK, like the EU, has committed to carbon neutrality by 2050, so essentially making sure that they're not adding any more carbon unnecessarily into the environment, and that's across the board. That seems like a long way off, but that will come around pretty quickly, and there's a huge amount of work to do. And the other key thing to note as well is that net zero operational efficiency, which, as you'll find out, comes into the RIBA 2030 framework, is very much possible today. So this isn't kind of pie in the sky. This is actually very practically capable. It requires some decent thinking and design to go into it, but nothing that you'll see in the RIBA 2030 framework is not achievable to this very day. And I want you to bear that in mind for the remainder of this webinar. So the four key areas that this RIBA 2030 document touches on are operational energy demand, embodied carbon, potable water use, and core health and well-being. And we'll go into those in detail, but really, as I say, this first section is about covering the document. And the arrows on the little quadrants there in the top left-hand icon shows a 75% reduction. That's really showing you for operational energy demand, we're looking at a 75% reduction on current standards. Embodied carbon, which is the top right emblem there, with a 50 to 70% reduction. That is what is being requested, so 50 to 70% depending on whether you're domestic or commercial. Potable water usage, which is the bottom left-hand icon, they're looking at reducing that by 40% over the next decade. And core health and well-being, this is a new one, and we'll go into this in more detail. So this is really just making this a key part of design, and there's no such kind of reductions as such. It's including it in the framework and introducing it. So as I say, this is a nice little graphic that forms part of the RIBA 2030 document, and this is for domestic buildings. There's a fair amount of detail in here and lots of numbers. Don't get particularly confused by those. essentially what is key to pick up here is that you've got the main sections, health and well-being, on the next slide, but operational energy, embodied carbon, potable water usage on the rows, and then the columns here going from kind of pink or red through amber, green, and dark green there as the decade progresses. So this is really just the kind of the framework. And what they're saying is at the moment, the red column here, this is where building regulations has us today. And then progressively, as we move on, this is ideally what we should be following to get to the end of the decade. Now, there's nothing stopping you doing better than this today. You could aim for 2025 targets today if you wanted to, but this is just walking you through the reducing numbers. And to give you an idea here, really, certainly as far as operational energy is concerned, the 2030 target here is very, very similar to Passive House. So that gives you an idea of the change that's got to go on here. Non-domestic buildings, the numbers are slightly different, but essentially the framework is the same. Again, I'm not going to go into mega detail here. The numbers are actually bigger compared to the domestic figures, certainly for operational energy and embodied carbon. Potable water usage actually is down. So this is more suitable for kind of residential buildings and things like that have a higher density of people in them. This slide here, this is about health and well-being, and this kind of has a slide in a section of its own. This is actually kind of something new. Shouldn't be surprising, really. I mean, we all like to live in healthy buildings. We all like to be well. But this is really kind of setting some standards. So what does that mean? So if you're going from something quite emotive to something which is actually pinned down by kind of figures here. So this part of the framework outlines what this means and the kind of the targets that they're setting. So for overheating, this is, to my mind, one of the most kind of important aspects of this section of the framework. And this is saying really beyond 28 degrees, if the building exceeds 28 degrees for more than 1% of the occupied hours of the building, then really that's kind of outside of the scope. I don't want to go into mega detail about CIBSE standards here, but to give you an idea, the current CIBSE TM59 standard, which is for domestic buildings, sets that target at about 3% of occupied hours. So this is kind of 3 times better than that target. So from my point of view, this takes some serious analysis to make sure that the building is within tolerance, and for some will be a real challenge and needs to form the basis of analysis going forward. Daylighting, greater than 2% average daylighting factor, 0.4 uniformity, means very little to a lot of people. Essentially, this is just setting a fairly run-of-the-mill daylighting standard. CO2 levels, again, 900 parts per million. Let's not get lost in the detail. This is really just sensible levels of CO2, which fundamentally means just good ventilation. Lots of studies, CIBSE studies, have shown that CO2 levels are directly proportional to good ventilation. So this is saying good ventilation and a comfortable thermal environment. And then you've got VOCs, so volatile organic compounds, below a certain threshold, and formaldehyde. Now, these are going to be really, really tricky to analyse, if not impossible. Essentially, I guess you could measure them at the post-occupancy evaluation stage, but they're in there for completeness. But really, it's those top kind of 2 or 3, and I would say specifically overheating that needs to be paid particular attention to going forward practically. So that's a really, really quick kind of whistle-stop tour of the RIBA 2030 framework. It's quite a simple document, actually. Very impressed by how simple the document is. Usually these things can run onto pages and pages. But hopefully what is most meaningful for everybody listening in is kind of an interpretation of what the practical steps are. And I think this takes the bulk of the thinking, how you turn something from a paper document into something that you deliver on site and can properly inform the kind of the design process. So we'll go into some more explanation of the particular areas here. And again, our take, Mesh Energy's take, my take on what a building looks like to achieve these targets. And so to start with, let's start with operational energy demand. And the definition for this, and this is really clear here to to be crystal clear about the numbers involved, to making sure we're fully capturing this. And operational energy in this is split into kind of two parts. So we have regulated components and we have unregulated components. Think of regulated components as the things that you would need to keep the building, you know, warm, properly ventilated, and kind of functioning, almost kind of whether there were people in it or not. There is lighting involved in there. So kind of core heating, cooling, hot water, fans, pumps, lighting that would just kind of keep a building running normally. The unregulated part of this is actually kind of use specific. So we're talking about, you know, for a house, you may have certain devices. For a laboratory, you may have other devices. For a manufacturing facility, you may have other devices. And those are very use specific. And this is the unregulated part. So there's a kind of a baseline bit and then a piece on the top, which, depending on what the building's used for, increases or decreases. And this is the definition of operational energy. You need to think of both of these things and factor both of these things in to the RIBA framework numbers. So what I've decided to do, rather than doing kind of domestic and commercial here, we've just kind of focused on domestic for the sake of this webinar and looking at the practical implications here. And this is really how we see the profile of buildings as these targets get tighter. So we've looked at the U values here for the main fabric elements. We've looked at air tightness, heating and hot water technologies, ventilation technologies, and then kind of on-site energy generation. So we're talking about, first and foremost, kind of solar panels effectively, and potentially battery storage. So where we are today, run-of-the-mill, nominal building regulations, U values, a decent gas boiler, mechanical ventilation that we'll all be familiar with, and no on-site energy generation. You could meet the 146 kilowatt hours per square meter per year by just boshing in the nominal U values for a home. When we look at the 2020 target, which is where we are today, you know, the U values have tightened up slightly, not massively. We're talking about a kind of a just over 10% increase in improvement for the main bits there, and windows again kind of getting 10-15% better. Still in double glazing territory when it comes to the windows. And the air tightness values here, sometimes it's difficult to kind of get a handle on air tightness. An air tightness level of 3 is nothing particularly fancy, a decent quality build, attention to detail when it comes to openings and how they're fitted, and services that you might have kind of punctured the fabric of the building, making sure they're properly sealed and not unnecessarily leaky. Buildings can achieve 3 just by doing that, just by paying attention to detail. You haven't got to tape joints at this stage. This is kind of borderline mechanical ventilation and heat recovery, and we've actually included that in the suggested ventilation technology. Heating and hot water, you're definitely having a look here at air source heating, potentially ground source heating, and underfloor heating. So it's the next step on from kind of gas boiler efficiencies. And everything from kind of nothing to a bit of solar photovoltaic technology. Again, every project will be different. This just kind of gives you a bit of a snapshot that's going to give you a decent chance. So moving on to 2025 and on to 2030 particularly, as I say, really we're here at kind of passive house levels of insulation and fabric efficiency. We're definitely in the realms of triple glazing here, and air tightness is sub 1 square meter per cubic meter per square meter per hour, and essentially, you know, passive house is down at 0.6. You don't need to get that ridiculous with air tightness, but what you are into here is really having a very airtight structure, you know, taping joints, having somebody who's looking out for making sure that there is fewer holes in the home as possible and that they're properly taped up, and detailing of the build and maybe specific build types like SIPS panels, off-site manufacture will really help in meeting these targets. You've definitely got renewables there, mechanical ventilation, heat recovery. A fair chunk of solar, 4 kilowatts is around 12 to 14 solar panels, and potentially using battery to save any excess electricity to offset any nighttime usage. So as I say, these are just our ideas, and we think they will get you pretty close. We've been involved in projects that have got to these 2030 targets, so I can tell you with a fair amount of confidence that they will get there if you base your designs on this. But this just kind of gives you a flavour. It gives you an idea of how much change is involved practically for a building. So embodied carbon, this is an interesting one for many people, other than for a very few specialists. It's been floating around for a while, and I've got to be honest, hands up here, for me and for Mesh Energy, this is out of these kind of 4 quadrants for the RIBA 2030 framework. This was the biggest unknown for us, and very tricky. Where do you start, where do you stop? And what is clear, from the RIBA 2030 framework is, it's reasonably all-inclusive. It's essentially its whole life cycle carbon analysis. And the definition for embodied carbon here really is the carbon footprint of the material. Considers how many greenhouse gases are released through the supply chain, includes everything from kind of extraction materials through transport, refining, processing, assembly, as well as the end of life profile. So everything from kind of maintenance and replacement through the building, but also recycling, demolition, all that kind of stuff as well. So really is kind of cradle to grave, as they say, as far as the kind of the embodied carbon for every single element of the building. And for a lot of people, that just immediately is a massive headache. There's lots of numbers. Where do you find reliable information? And again, we'll go into that. It's been made a lot easier recently to do that with software and various tools at our disposal. So don't despair. This is getting a lot more simpler and a lot more available. So embodied carbon, as I say, over the next decade, this is looking to be decreased anything by kind of 50 to 70%. But if we understand what that is today, I think most of us may be surprised how far we've actually got. But most of us don't know what those numbers are at all. So this focuses us in on that particular area. Embodied carbon, areas to improve. So again, there's particular focus here on retrofitting buildings rather than building new things. Of course, buildings that exist save a lot of carbon because those materials are already on site, save a lot of energy. There's a lot of focus here on fundamental circular economy principles here, like recycling, sourcing local materials, and minimizing residual waste to an absolute minimum, and reusing materials wherever possible. And also in the RIBA 2030 document, there is a touch on offsetting emissions by offsite renewable energy projects or kind of woodland planting. I think this really does factor in more on the commercial side rather than domestic, but it is in there as a document as a kind of a legitimate way if you can't quite get to targets, by essentially buying credits or offsetting carbon by other means. This is a really interesting graphic, actually. I say we don't need to worry particularly about the mega detail here, but it gives you an idea of trends, and this is from CIBSE documentation. It gives you kind of office, warehouse, and residential here, and it's a breakdown of where embodied carbon factors in, and what proportions there are for embodied carbon when essentially the keys are handed over for the building to actually build it and to kind of practical completion, the proportions involved in actually running the building, as well as kind of replacement through the life of the building. So to give you an idea here, if you look at the residential one, the dark orange or the deeper orange is about embodied emissions up to practical completion. So before somebody's walked through the door, you've essentially got 51%, so half of the embodied carbon in that building, whether it's used or not. However it's used, the next 100 years, half of that carbon is in the building by the time you hand over the keys. The lighter orange bit there, 18% in this particular case, is about replacement. And over 80 years, 100 years, how much carbon is in those bits that you replace and renew. And the dark grey and light grey there are this kind of regulated and unregulated kind of operational carbon emissions. So heating it, lighting it, energy, electricity for ventilating it. And that's surprising to some. I think I personally didn't think that half of the embodied carbon would be in the building when it's built. You would think a lot of it would go into running or heating the building, particularly over a century. So this is really surprising and tells us a lot about the effect that we can have by better material selection and smarter material selection, and using software and data during the design process to really dramatically reduce the embodied carbon at that very early stage. And again, this particular slide just kind of shows you the typical buckets here. So you've got these various stages: the product stage, which is A1 to A3, construction, use, end of life, and then kind of benefits, loads, demolition, recovery, recycling potential. And when we're looking at embodied carbon, it's one thing having a look at what the total figure might be, but what's really interesting here is different materials will have different profiles depending on where they're sourced, how much processing is involved from raw materials, as well as kind of turning it into, some say super duper insulation material, how easy it is to recycle. And what's fascinating here is I think focusing on this section will give us, really lift the lid on the profiles of these materials and really focus our minds on, and maybe even surprise us at how much embodied carbon there is at these different phases. And once we understand how these things are profiled, we can get better. And this, the key to the whole embodied carbon piece here is increasingly these environmental product declarations, or EPDs, another three-letter acronym that we all love. And these are essentially, for an increasing amount of products, these are third-party verified certificates that essentially can be relied upon to tell us what the embodied carbon is of a particular product, whether that's PIR insulation, whether that's a clay tile, whether that's a building brick, or an RSJ, say, for a construction of a building. And these have been verified. They tell us in detail for the various chunks of the process what the embodied carbon is in there. And this saves, as you can imagine, because they're verified, they come from different sources, but they're verified in the same way, and essentially they're normalized. And this allows us as design professionals to draw on this data, manipulate the data, compare it against our designs, and save ourselves a whole load of headache and give us some really reliable feedback. So again, without going into mega detail here, environmental product declarations are our kind of savior when it comes to this. And there's over 8,000 currently. There's quite a few to pick from. Products that are sourced globally, that's all factored in as well. And this is actually a kind of a UK-based thing as well. So we haven't got to make any kind of fudges to make it make sense for the UK market. And these all factor in transport from overseas or Europe, or wherever it is. So very, very reliable information, and there are thousands of products to choose from. Potable water usage, the definition here for the kind of the third chunk or third section of the RIBA 2030 framework is around potable water. And this is very, very simple definition: drinking water, or stuff that's kind of safe to drink or to use for food preparation. Pretty basic. And the idea is that we try and reduce usage over the next decade by about 40% from where we are today. And again, what we've tried to do here is give you an idea of practically, how you would deliver this. And this is today, so is based on the technology that we've got and the calculations which we've got. Now, potable water usage factors into Part G of the building regulations. And typically speaking, most planners at the moment are asking for proof that we hit the 2020 target, which is actually less than 110 litres per person per day. So most of us are already there, and that can be achieved by dual flush toilets, low flow restrictors on showers and things like that. Solutions we'll already be familiar with, and unless we've got particularly luxurious about baths, is very, very easy to achieve. The 2025 targets and the 2030 targets, although it doesn't appear to be a massive reduction there, are actually surprisingly tricky. So you're into kind of rainwater harvesting territory. when you look at less than 95 litres per day, and potentially some quite advanced greywater harvesting techniques to get less than 75 litres per day. It is predicted, I mean, our educated guess is that as, you know, kind of toilet technology and things move on, that's where a lot of potable water usage comes in of a day, is toilet use in a home, and certainly a domestic building. Advances in that kind of technology and shower technology will help us get to these lower targets as the decade progresses without having to invest in cumbersome and quite costly kind of greywater harvesting technology, and potentially rainwater harvesting technology. So this is today, but we will see advances here which will hopefully allow us to keep costs kind of under control and still meet these targets. And then kind of finally in the RIBA framework here, we've got health and well-being. Now this is a new section, and the way that this is defined, as well as the way that health and well-being is defined by the WHO, is a kind of a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity, which is good to know. And well-being specifically refers to a positive rather than a neutral state, framing health as a positive aspiration. And hand on heart, you know, I think we want to live like that, and it surprises people that that has to even be defined or focused on. But I think as technology has rapidly progressed and buildings have progressed, some of the side effects of rapid advancement have meant that certain aspects of health and well-being have not knowingly or intentionally, but they have been left behind. And I'll go into that in a bit more detail. There's certainly a growing pressure from clients, you know, through press and media and stuff. Air quality, as we sit here today, is very, very kind of top of the list. And so this is a really kind of critical chunk of the framework. And I'm really pleased that this has been included. And there's been some kind of sensible figures put against it as well, so that we can design better buildings and then measure against those once the buildings are occupied. And so, as I said at the start, there's this kind of CIBSE European standard called TM59, which specifically focused on domestic buildings. TM52 is the kind of more generic equivalent of that, but it sets as one of the overheating criteria. It sets 3% as the kind of the benchmark for acceptability. There are other criteria, but the first criteria is about kind of cumulative overheating throughout the period of the year based on total occupied hours. And this target, health and well-being target, is tight. This is 3 times tighter than that target. And we've already come across buildings that are failing even that first target. So this will really focus the mind on overheating. But practically, you know, we are going to need software to solve this problem. We cannot rely on our experience anymore. You know, things are getting pretty tricky here, and there are loads of variables. So we are going to have to rely on software and a better way of working. CO2 levels, as I mentioned before, really CO2 levels are an indication of ventilation effectiveness. So as long as we've got a good ventilation strategy, then we should be okay on CO2 levels. Commissioning is really key of systems, so there's a lot of practical applications or things to consider there. And post-occupancy evaluation and measurement, both for CO2 as well as temperature, are going to be really key to prove that our designs are actually manifesting themselves in proper environments at the end. And VOCs and formaldehyde, I mean, total VOCs, when you talk about VOCs in this context, are really talking about more responsible kind of paints and coatings for things, man-made materials, particularly trying to alter the chemistry in those, so there are less organic compounds, which more and more people are becoming sensitive to. And formaldehyde really there is talking about glues and adhesives and things like that. So we see very high formaldehyde concentrations. So again, you know, really, really difficult to design into a building, but does focus our mind on more responsible kind of purchasing of products and understanding where those come from and the kind of the characteristics of those. And kind of the final chunk of the webinar here, which I think is really important to understand. As I said at the start, you know, all of this stuff is not pie in the sky. This is achievable. And what is, I think, to start joining the dots here, what's really important is for me to try and explain what tools are available today to deliver, for you to understand where you are against these targets, and to confidently be able to deliver against these targets, improve designs against these targets. Again, it's one thing knowing where you sit, it's another thing improving, or knowing how much you do have to improve. You know, money always talks, so you know, there's no point in throwing bags of money at this stuff if it's unnecessary, but it is worth focusing on and finding out if design improvement, or in some cases drastic design improvement, is required. So this last little bit is just on kind of tools and assistance that can be provided. So this was the kind of the best way here that I could show what I'm talking about and how you can deliver against these different pieces of the RIBA 2030 framework. So Mesh Energy, as I said, delivers a whole load of services for architects and design professionals. And for many years, we've been designing our own kind of software and in-house calculators. And, you know, real kind of bread and butter for us is kind of feasibility, technology strategy, helping people with capital costs and renewable heat incentive, government subsidies for putting in sustainable technology. And those are standalone reports. And as part of that, out drops, you know, what we think running costs are, and so what we think some of the operational energy characteristics are of the building if it's built as to the design. Part G water calculations at the very bottom there comes from building regulations and is directly what you would use to figure out what your potable water usage is. It's a pretty kind of standard calculation, nothing fancy there. But there are elements of operational energy usage, embodied carbon and cost, and health and well-being, which are really kind of gaping holes at the moment in both our offering as well as kind of tools that can be used to help you guys out as architects and design professionals. And the way in which we meet this is by making thermal modeling the kind of the keystone to early stage design, and then building on that using kind of modules that are readily available, are accessible today. You know, we've got this technology in place, and using those modules very, very effectively as part of the early stage and developing design process. Because once we better model the environment and better model using these EPDs that I was talking about, a lot of this information you need against operational energy, embodied carbon, cost implications, and health and well-being falls out and is there in plain sight, and you can interrogate these, improve these, and the feedback loop becomes very, very quick and very, very valuable very, very quickly. So to give you an idea, to meet the operational energy piece in the RIBA 2030 framework, there's another CIBSE standard called TM54 that's specifically around operational energy. You can do that out of the thermal model. There is the RICS pricing database and verified EPDs, which help you with embodied carbon and cost and the relationship between those two. That comes out of One-Click LCA that works hand in hand with the thermal model. This thermal comfort analysis that I was talking about, that comes out of the thermal model. And the CO2 and daylighting, that comes out of the thermal model. So what we're talking about here is a kind of a fundamental shift to putting thermal modeling and some of these key modules at the heart of everything that we do. And Mesh Energy have started that process now, and by using that can offer consultancy against the 2030 package, starting from today, which is kind of late April 2020. And this is kind of really exciting looking at it this way, because I think this the RIBA 2030 document has acted as a kind of a real catalyst for improving the design standards, elevating all of us to a new level, and getting us thinking as a consultancy about how we can deliver that for a kind of a sensible cost and deliver much better value to you guys as architects as well as clients. And so I thought of another graphic as well, which kind of helps you look at the kind of the stages here. Again, we're not going to go into mega detail, but this gives you an idea based on the kind of the stages. So on the far right-hand side here, we've got various tick boxes, which is essentially where you ping the various modules of the RIBA 2030 framework. And using thermal modeling, we're talking about getting involved here at a very early pre-planning and concept design stage. So this would be very much a kind of a close working with you guys as architects. It's up to you whether you pass this kind of cost on to the client at this stage. But what is becoming obvious is there is the opportunity for R&D tax credits at this early stage. So if we work business to business, there's an opportunity to make a saving against corporation tax at the end of the next financial year. As the project goes through planning, you get into detailed design. You've done all the hard work with the thermal modeling. You've got some idea about embodied carbon, and really the detailed design process can get off to a flying start, and you've got some real teeth there. And it doesn't have to cost a ton of money to get this stuff done, but really gives some amazing tools at your disposal to get through this process very, very robustly and very, very intelligently. And then into the kind of the build phase, because you've used these EPDs and you've got this software, the house is already designed, it can help you even further refine, the best materials to low carbon materials to make the building from, right up into the last minute. And then handover in use, you're into kind of monitoring and measuring against the RIBA 2030 framework. And of course, one thing that hasn't been mentioned so far, and maybe some of you are already aware, but without following this RIBA 2030 framework, without putting numbers against this framework, really you're dead in the water when it comes to awards, certainly RIBA awards going forward. So if you want to remain as a progressive practice that is award winning, that wants to win RIBA awards, which are very highly sought, you need this information. This, based on feedback from other architects, this is forming about 60% of the application process. And if you've gone through this as a standard part of the design process, those numbers just fall out at the end. So really it becomes very, very easy to make those applications when you're going for awards. And when we look at benefits here, again, they're numerous. So you're looking at, just greater levels of confidence in the building geometry before you go in for planning. If something does need to change, you know about it. You haven't got to go in again for planning if you realise there's something been picked up by detailed design, particularly when it comes to overheating. So, the overuse of glazing, or maybe you've gone under on overhangs, or those kinds of things, building furniture on the outside that would affect the planning process. Find that out before you go into planning, and that's the real gold dust at that stage. But again, through detailed design, you're talking about reducing running costs, unnecessary capital expenditure, clear and easier contractor negotiations and things, and a whole raft of other benefits. I'm not going to go through every single one. You can obviously pause here and have a look at these in detail. So we're really excited about this, the RIBA framework, and we think it's kind of eminently deliverable today. This isn't pie in the sky stuff. And just to kind of finish up here, this is just a kind of an overview about Mesh Energy. As I say, one of our unique selling points is a kind of nose to tail consultancy. We can offer everything from kind of energy calculations and modeling, pre-planning, all the way through to kind of full M&E design for everything, as well as renewable tech, installer recommendations, subsidy assistance, helping you on site, and even post-occupancy evaluation. So I'm going to wrap the webinar up there. I'm going to leave that last slide with you. Thanks very much, guys, for for your time here. Always happy for you guys to pick up the phone and speak to us about how we can help you guys out. As I say, I will be doing more webinars on 2030. This is an exciting framework, and we're going to shortly be doing some case studies for you as well. So thanks for listening, guys. I appreciate your time. Stick with us. We'll be doing loads more webinars and look forward to seeing you there. Take care.